Okay, so we're going to configure OSPF now. Now you've seen a quick OSPF configuration, but now in this topology, we're going to go ahead and configure OSPF and get into a little bit deeper areas of OSPF and how it creates its neighbor relationships. So we're going to go to the first router on the left, which is labeled router 5, and we'll fix our window so we can see all the information. Let's hit enter a couple times. We're going to enable. We got to go into global configuration, and then we start our OSPF configuration. So we go router, OSPF, and again, the process ID number, we have from 1 to 65,535. We're going to use just 1. Doesn't really matter, it's local. Then the network 192.168.1.0. The wildcard mask is a 24 mask, so we got 0.0.255. And then the area, so we can share the same routing tables. Area 0, remember, is your backbone area, right? That's the first area you would create in a real world scenario. The next one would be network, and I just want to verify. Let me move this out of the way real quick. Okay. Would be 10.1.1.4. It would be a CIDR 30, so 0.0.0.3. And then area 0, and you hit enter. And that would be it. Let's do our shortcut to copying this configuration. Do WR. And we hit enter. So we're done with router 1. And let's go to router 2. Now in router 2, we have 3 networks. We have the 10.1.1.4, the 10.1.1.8, and the 192.168.2.0. So we're going to go ahead and click on router 2. Hit enter. Enable. Config T. And we start our routing process. Router, OSPF, 1. And the only reason I'm using 1 over again is just consistency. I just want to use 1. I don't want to keep changing the numbers and trying to keep remembering which numbers I used. Network, 10.1.1.4, 0.0.0.3, because we're using a CIDR 30. Area 0 must be the same area. Now, when you hit enter here, sometimes it takes a little bit, but since it's going to recognize the other OSPF and it's going to create a neighbor relationship, and it's going to say full loading done. It takes a little bit, so I always like to wait for it to happen, because if we don't type in command called logging synchronous within line con 0, it's going to interrupt your process. As you can see here, we has just built an adjacency for process 1. This is our neighbor that on 0001 we learned it on. And this right here is what I want you to really pay close attention to, full. And we'll look at this a little bit deeper, because this is a state that this router or this interface is in. Because in order for 2 routers to become neighbors, they got to go through a series of states before they actually say, hey, we're neighbors now. Let's continue the configuration. Let's finish it all. Network, 10.1.1.8, 0.0.0.3, area 0. And then we have the LAN, and I just want to make sure it's the 2, okay? So network, 192.168.2.0. This is a 24 mask, 0.0.0.255, area 0. There we go. So our shortcut to copy, do WR. Well, why didn't we get any updates when we did the 10.1.1.8? Because it's the last router. We haven't configured yet. When we do the last router, we'll get all those updates. You do want to see something that says full loading done. You don't see that, then we have an issue. Let's go to the last router. Enable, EN for short. Config T, router, OSPF 1. Network, 10.1.1.8, 0.0.0.3, area 0. And again, once you hit enter, I always like to wait, like I said before, because I don't want to get my typing interrupted. And I haven't typed that command. There it is. We created a relationship right there. I'm going to hit enter. I'm going to enter my last network for my LAN, which is 192.168.3.0, 0.0.0.255, area 0. Shortcut for copying, do WR. So let's do a Control Z, and that takes us back to privilege mode. And we're going to do a show IP route. Now you can see that we have O's for OSPF. But wait a minute. Didn't we have RIP on here previously? We sure did. But what happened? Well, take a look. The administrative distance of OSPF is 110. What is the administrative distance of RIP? 120. So the lower administrative distance will have priority to get to the routing table when you're looking at the different routing protocols. So we have OSPF now that overwrote RIP, and it's in the routing table. So we are routing right now, but let's do a test. Let's go ahead and do the test to see if we can really ping across the network, because we are learning about the 192.168.1.0 network, which is right here. So what I'm going to do is I'm going to click on the server. And from the server, I'm going to expand a little bit here. I'm going to go to the desktop. I'm going to go to command prompt. And I'm going to ping 192.168.1.1. And remember, this is Ethernet. The first one is always a request timeout, and the second one should be a reply. There we go. That happens because of the ARP. If I were to do an up arrow again, there is our 4 replies. But let's go ahead and keep checking, make sure they have connectivity across the entire one. Let's do 2.1. You always want to check, and for those of you that are taking a certification exam, always verify if you're configuring something that you are pinging across. All right, so we have full connectivity. But let's again keep exploring a couple more things in OSPF. Let's go to the same router and let's do show IP OSPF neighbor. I always put you can tab and hit neighbor, but sometimes I misspell it. So tab key is your friend. And what you're looking at is the state, which is full. And that is very important, all right, because there are like 5 different states that OSPF goes through. You have a down state, you have an initialization state, you have a two-way, keyword right there, two-way state. And then you have an exchange state and then the loading state, which makes this the full. And why did I say a two-way? Because OSPF is very picky. If you look at any interface, let's take a look at a serial interface real quick. Show IP OSPF interface S0/0/1. Enter. What are we looking at? What do we want to look at? Well, right here we see the internet address, what it is, and that's fine. More importantly, here we got the router ID. What is the router ID? The router ID, when we configure OSPF, it's the highest IP address on any physical interface, which that is the highest IP address. Next important thing is it's a point-to-point network, and it has a priority of 0. And take a look at here. You look at your hellos and your deads. Again, don't mess with these. These got to be the same from interface to interface, or they will not talk to each other. But you can see this priority of 0. Why is this 0? Because this is a serial interface, right? We looked at the serial interface. It considers it a point-to-point. Why does that matter? Well, let's take a look at the fast Ethernet interface. See what that does. See if we see anything different. Uh-oh. Now we see something different, don't we? We still see the same router ID because the router ID is the name of the router. That's how the router sees its name. Hey, I'm 192.168.3.254. But the type of network is broadcast. It's no longer point-to-point. And now it's a 1. So that means that OSPF in a broadcast environment runs an election for what? A router ID, a designated router. So who's the router ID? I am. Because really, when you're doing OSPF in a topology like this, which it is point-to-point, no election is going to run across the network. But if you have a topology that exists with a switch and then let's say 4 routers or a frame relay, that's a multi-access network. It will consider it a broadcast environment and run an election for a DR. But as you can see, the configuration in itself of OSPF is not difficult, but there's many things that you need to look at when running OSPF. And definitely when configuring OSPF, if you do not see the full loading done, something happened. So you need to check, hey, what's going on? Are we in the wrong area? Did we type in a wrong wildcard mask or what? But this is your OSPF. We do have connectivity. It's very simple at this level, but it could get a lot more complex when your network infrastructure grows.